In this video, we're going to talk about thread pools. What is a thread pool? So starting a new thread for every task can limit throughput. It could cause poor performance. So maybe we have 100 different tasks we want to run, right? And we're going to see some examples of that a little bit. But if they ran all at the same time, maybe they would cause a problem because it would just put too much stress on our system. So we can use something called a thread pool to manage how many tasks can actually execute at the same time. JDK 1.5 and above uses the executor interface for executing tasks in a thread pool, and the executor service interface for managing and controlling the tasks. The executor service is a sub interface of executor. Now, what's all that mean? We're going to create an executor. It's going to manage all of our threads for us. Basically, it is what it means. So we're going to see examples in just a second. So you can look through here and you can see, we can tell it to execute a certain runnable object, but we can also, in order to use an executor object, we have to use some static methods that are contained in the executor's class. And these are some of those static methods that create the thread pools and creates new threads as needed. So let's take a look at the example we've been looking at that's done with a thread pool. It's not as complicated as it sounds. So executors class, we said we were going to use some of the static methods in that. We're creating a new fixed thread pool and storing that as an executor or an executor service. Okay, so that's the line that you need to do to create a thread pool. We're creating a pool that allows 3 threads to run. And then we're creating our new tasks down here right inside the executor.execute method. So this executor that we created, we're calling its .execute method. And we're saying, hey, here's a task that we want you to run. So we could have done this in separate lines, but we didn't. So we're creating these on the fly. So we're creating a print character with A's, 1,000 of those. Print character with B's, we'll get 2,000 of those, and a print number with 1,000 numbers. Those are our 3 tasks that are going to run. And our thread pool says we're allowed to run 3 tasks at a time. So let's run this and see what happens. Okay. And we can see that all 3 threads end up running. We start with a bunch of A's and B's, but eventually in here our number counter kicks in and they're mixing, they're going back and forth between the different threads. And you can see all 3 threads are running. Eventually, some of them finish. The letters before the numbers seems to be the way it always works. And our numbers finish up at the end. So all 3 threads ran at the same time. Now, let's do this. Let's switch this to 2. Only 2 threads are allowed to run at one time now. But I'm creating 3 threads here. So what happens? Scroll back here. We can see our A's and our B's because we start those first. A's and B's keep running. And the 3rd thread is never allowed to start until the A's and B's finish because we can't have multiple threads, more than 2 threads running at once. By that same token, if we decrease this to 1, this says, hey, only 1 thread's going to run at a time. And in that case, we get all our A's, then we get all our B's, then we get all our numbers. That means they're running sequentially, and that kind of defeats the whole purpose of using threads to begin with. But I just want to show you how it works. Okay, so we can have a ton of threads running, and the thread pool will limit how many actually run at one time in order to keep our system from getting overloaded.